transaction is all or nothing. If part of the transaction fails, the whole transaction fails, and the database is left unchanged, even if there are power failures and system crashes. Okay? And you really got to give the database people credit for what they've built. It is phenomenal the way the systems work, that they actually do that. If they don't get to the last stage and say everything's good, commit, then the power goes down and nothing happened. The data's back to where it was. Consistency says each transaction will take you from a consistent state to another consistent state. You will never get caught in the middle where you've updated a couple of records, but this record has old data because you haven't finished calculating it before you're there. So atomicity is all or nothing, and consistency says you never have data there that's one part of the data is inconsistent with another piece of the data. Isolation, again, this is a hard one. The database people are fighting two things. They're fighting performance, which makes them want to do everything in parallel, and then they're fighting these constraints. So if you just have one database and one user, I mean, this is a piece of cake. But if you have a database that has 45 databases on it, and they're all being accessed at the same time, then what will happen is, one will start doing a couple operations, and another's doing a couple operations, another's doing a couple operations, right? And none of these can cause any of those or those or those, and none of these can cause those or those or those to ever be wrong. Again, assuming the worst case, the power fails. No interaction between one set of updates, and this is not only between databases, this is between like multiple people reading and writing in the same database at the same time. Multiple transactions within one database cannot, if it would fail, cannot cause the database to be corrupt. And then durability says is once you've committed it, it is there. And this is within reason. What this really sort of means is it's written out to multiple disks. Now, if the whole building burns down and all the disks melt, well, it's not durable. Companies replicate their data like 30 miles away so that they can tolerate a hurricane or something, and they can actually survive this kind of a thing. But this puts a price into your transaction, which means when somebody says, I bought it, you can't acknowledge and say, it's mine, you got it, until not only have you written the database here, you have to wait for the database at 30 miles an hour to say, yeah, I recorded it too, so it slows every transaction down. All of these things slow transactions down. It's a whole science to itself. And then sort of in direct opposition of this is this CAP theorem, which says it is impossible for a distributed system to provide consistency, availability, and partition tolerance. And you pick which 2 out of 3 you want. And what you'll see with Hadoop is it's going to have a lot of partition tolerance, it's going to have tremendous availability, but it gives up consistency. You can ask, 2 different people can ask the same question at the same time and get 2 different answers because they might get data from different drives that are currently being updated. And then these are some trade-offs you can make when you build your system. You can use two-phase commit, which is what SQL does, but when you do that, if you have a distributed system and one side can't talk to the other, you have to shut everything down because you're not allowed to proceed because you might corrupt the data. So you'll lose availability, but you'll strengthen the integrity. Or you can say some of the data is accessible, but the rest is not. And that's a situation where if you have a failure, you can isolate it and say, well, it's only these tables on this machine. I will let all other accesses continue, but I will refuse these ones. So there, most of your data is accessible, but some of it's not. And then this is the partitioning one, which Hadoop does. You know what DNS is?
Yes, domain name service.
Yeah. This one's really interesting. Like, the whole world is now in a DNS system. So there are these servers all over the world. There's probably several of them in this college. Your Comcast home internet link has one. You can go into your web and say, who's my DNS server? So every time you type bellevuecollege.edu, your browser says, what the heck is that? Well, it goes to a DNS server. And if it can't find your DNS server, your machine won't work. Maybe you've seen this error. You can't find DNS server, and then you can't find anything. So it's a distributed name server. So it goes to wherever yours is, and it says, oh, Bellevue College is at internet address 171.3.3.64, and it transfers it into a real address. So what happens is when people put up new sites and change sites, these addresses change. The name Bellevue College and the real IP address sometimes change. And it's a pretty cool system because what will happen is, like, we'll change it here at Bellevue College, and then some DNS server in Seattle will try to access us, and it'll fail, and it'll say, oh, my DNS must be updated. So it'll contact this DNS server, and it'll say, here's the new data. And then it works like a spider going all across the globe, all the DNS ones, and it takes somewhere between 10 and 15 minutes sometimes before, if you make a DNS change, before they all have the new address. And that's an example of this eventually consistent data. And what it means is, once in a while, some people can't find a computer for a few minutes because they change an address. That's okay. I think there are going to be, if they're not already, a zillion jobs in this area. So when we get done with this, we'll be done with it in probably, I don't know, 2 weeks or 3 weeks. You know, you might want to seriously say, like, ooh, that was pretty cool, I like that. And you might really want to seriously pursue it as an expertise to acquire, because it is a huge and huge growing area. There's probably a lot of jobs there. And this is another aspect I didn't bring up, and again, this is a trivial list, but for whatever crazy reason we live in this world now, people want to publish their data and make it available, okay? So there's an online book repository where there are a bazillion books are now, this is not Amazon, not paid for. The books are just sitting there. We're actually going to pull some down when we do our MapReduce product. The New York Times has all their movie reviews online, and they've exposed an API. There's a site that has 20 big data repositories you check out. And again, this data is a year old. I bet you there's zillions and zillions and zillions of interesting things. So you can almost start to think of this as interesting business opportunities. Like, given all the publicly available large data sets, what could you do and charge money for? You know, Google decided people might want to search, and you know, $800 billion later, look where they are. So now we'll show them some do. Okay. I think we're going to call that a day. So again, if you turned in something for homework before midnight last night, and it'll generate at least one record up on the node server, then you'll get full credit. If you didn't, maybe you can get it working tonight, in which case you get 7 points. As far as making it work for multiple nodes, I'm definitely going to give you at least another week for that. Again, it's really almost not germane to this course, but it's just a review of what I hope you would learn. And like I said, if you're having trouble getting yours running, you can try submitting it, telling me what's wrong, and I'll try and look at it. But I probably won't be able to get through many of them, because it'll probably take me several hours on each one of them, but I will try. And eventually, I want everybody's to work, and I will continue to work with you until they all work. And by all means, use a discussion group. If you're working on it and you're seeing a surprising result, start a discussion topic and ask other people here. We have people here that definitely know the JavaScript better than I do. Now, I don't know if you guys do this, but I don't even know where it is anymore. But you should get a notification when things happen. Like if I grade your homework, you should get a notification in your mail. And if a new discussion, like I've started several new discussions, have you gotten a notification that I've started?
We need to subscribe that.
Subscribe to the mail, but they also show
I should use that.
Okay, so I would ask that you do that. You'll see that the nature of this course, this one, and then if you take whatever it is, 422 in the fall, and then the capstone, I really like to think of it as like we're in this together. I like to get everybody through all the material. It's not so much that I want to say, you know everything, you know everything, you know everything, you know everything. I want us all to get through it all and understand it. So helping each other is encouraged here. Yes? Okay. Okay. I think that's the most talking I will hopefully do in this class. Most of the rest of it hopefully will be actually writing code and playing with systems.
So Kurt, I could give you the other info so you don't, or for Bitbucket.
You could do